Have a good one, Tom. So number 57 here. We're given a truss as overhangs and heel heights. We have a heel of 12 inches, an overhang of 2 feet on each side. We're given a span of 32 feet. We're asked to find H. We're asked to find the slope. We are given that the top chord length is 23 feet, 5 3/16 inches. So let's proceed with this. We're going to start out by doing this right here, this triangle. It's not necessarily subtracting 2. The bottom of this triangle is going to be how big? This is 16 feet, but that triangle goes to the overhang, so it's a total of 18 feet. The next thing we have to do is we have to convert this top chord length into decimal feet. I start out with that 3/16 of an inch. I do 3 divided by 16, gives me 0.1875. I add that to the 5 inches. So that's 5.1875 inches. I divide that by 12 to make it feet. Very good. So 0.43229, and I add the 23 feet. So that's 23.4323, we'll call it, feet. Now we can find this height here. How? Well, we're going to use the Pythagorean Theorem going backwards. That height will be the square root of 23.4323 squared minus 18. Why is it minus? Yeah, because this was the hypotenuse, and I'm using going backwards to one of the legs. So, second square root. I'm going to square that answer and subtract 18 squared. Gives me 15.002. That's 15 feet. So I can now find my slope. P over 12 equals that rise of 15 over a run of 18. Cross, multiply, and divide. 12 times 15 divided by 18 is, come on now. Anybody? 10. There you go. So we've got a slope of 10/12. The 2 feet, I didn't find anything with the 2 feet. All I did was added that on to get the total run of this top chord. It was 16 feet, was half the span, plus the 2 foot overhang. Yep, that's, no, the 23.4 is this number right here. I just converted this into decimal feet. That was given in the problem. Does that make sense? All right. So the Pythagorean theorem was to find this height here. We were going backwards. So now that I have the slope, I can find my height. I'm going to come back to this triangle right here. It's not going to be the 15 feet. Exactly. It's not going to be the 15 because of the overhang. That's technically not the height. I should call that something else other than height. I'm going to go back to this little triangle, but I'm going to use 16 feet here now because I'm only going out to the heel, not going all the way out to the overhang. I use my 10/12 equals blank over 16. Cross, multiply, and divide, I get 13 and, not everybody at once, 13 1/3 feet. Does that look right? 1/3 of a foot is how many inches? 4. That's 13 foot 4 inches to there, plus 12 inches makes it 14.4. So the height is 14.4. Those aren't so bad, are they? It's just finding all the different triangles and piecing them together. The key to these is just making sure you know, are we including the overhang or are we not including the overhang? The common mistake that is made here is people want to take this number here and just subtract 2 feet for the overhang, but that overhang is measured on a horizontal. This is at a slope, so the amount that's going to be lost here is more than 2 feet because it's at a slant. So let's drop down to like number 61 through 64, our attic trusses. An attic truss, of course, usually one of two things happens, or both. They have a much steeper slope. They'll always have a heavier bottom cord, usually a minimum of a 2x8 bottom cord, because it's serving almost like a floor joist going across there. And then they have walls in them. Now, most of the time an attic truss looks something like this, where they have the walls put in here and then the ceiling is up top and there's a sloped portion of it, well, a vaulted portion of it. That gets to be tricky to deal with. So what we're going to deal with is a simpler version of that, where whatever our ceiling height is, that's where the walls are going to hit as well. So we don't have to worry about that vaulted portion. The math on that gets to be, I mean, it's not terribly ugly, but it's more than we want to deal with right now. So we're going to take a peek at number 65. For number 65, we've still got a little bit of an elevated slope, but in order to make our room a little bit larger, we also have an elevated heel. So here we have a 22-inch heel. I've seen attic trusses with as much as like a 36 to 40-inch heel on them, just so they can get that room pushed out further towards the edges. 26-foot span. We have a 10-12 slope on the roof. From the heel to the inner wall is 7 feet. I want to know the wall height, the ceiling, and I want to know the top cord length, and I want to know the overall height, total height. Well, the ceiling length is actually pretty easy to find because I've got 7 feet here. What do I have here? 7 feet. So the ceiling has to be 12 feet. Very good. So we knocked that one off pretty easily. Let's do W next. To do W, we're going to have to do this little triangle right here. That little triangle is 7 feet. I'm going to call that height X. It has a slope of 10, 12. So that's going to be 10 over 12 equals blank over 7. 10 times 7 divided by 12. 5.83333. 5 foot 10 inches, in other words. So this from here to here is 5 feet 10 inches. What's that make my wall? It's 5 feet 10 inches plus 22 inches, right? To make this a little easier on myself, 22 inches is how many feet? 1 foot 10 inches. So now we'll go ahead and add. 10 plus 10 is 20 inches. That's a foot. How many inches would be left over? 8. 1, 5, and 1 is 7. So that's 7 feet 8 inches. That's my wall height. That's actually really good for an attic. Most attics come out around 6'6" to 7 foot. Now then, we need to go back and find J and H. To do that, we're going to use a bigger triangle. I'm going to draw it on the other side so I don't confuse it with the other one. This one has, of course, from here to here is how big? Where did the 13 come from? Half the 26, half the span. Still a 10-12 slope. So we have 10 over 12 equals, I'll call that y over 13. 10 times 13 is 130 divided by 12. 10.83333, which is 10 foot 10 inches. We still have to add to that the 22. So 10 foot 10 inches plus 1 foot 10 inches. That's going to be 20 inches. So again, 8 inches, carry the foot. 12 foot 8 inches total height. Are you guys familiar with shipping at all? Shipping. Is boxing them up and shipping them out? It's a pleasant thought. Your standard truck bed, your maximum truck bed is allowed 9 feet. You are allowed to hang off of the driver's side 6 inches, and you're allowed to hang off the passenger side up to 3 feet. So that makes a total width 12 foot 6. So this is a 12 foot 8 truss. You would not be able to haul that laying flat. What you would have to do is you have to do what's called a pull truck. This is a very rough illustration of a pull truck. So the truss sits like this. The wheels are down here, like that. So now the point of that truss has to have a certain amount of ground clearance. A lot of places don't like to haul them this way because if you have rough terrain, it can damage the peak of the trusses. I mean, usually you only have like 5 or 6 inches of ground clearance there if you're hauling the statewide in Wisconsin, I believe standard overpass is like 13.4 or something like that. But that's why you call ahead. So anything over 12 foot 6, you actually have to call ahead and get permission to travel a route in Wisconsin. You know the other option, and this happens way more than you'd think. Is to do that. They just chop the peak off the truss to get that couple of inches so they can lay it flat on the. Then if this is a big enough piece up here that they chop off, if it's a small piece like here, they're only saving 2 inches. So they probably wouldn't even have to send anything to fill it in. They just have the carpenter fill that in when they framed in the roof. But if it's a big enough piece, they actually build a small little truss to stack on top of it. It's called a piggyback truss. Yeah. And pole sheds are very common. They don't haul well that way because you've got a lot of times you got the tails hanging down below the floor, so they're sitting on the tails, and some called partition separation. It's the plates start to pull apart and the joints weaken. Okay, any questions on those so far? Here we go. Next, I want to look at like number 67 there. Dual slope trusses. Dual slope trusses are a lot of fun. Something like number 67 there. This is not number 67, by the way. It is just similar to number 67. So we have 12 feet here. And on the other side over here, we have 30 feet. Now let's do this. So here's what I want you guys to find here. In this dual slope truss, I'm giving you that the overall span is 42 feet. This section here is 12 feet. And the height is 10. I want you to find this section, each of the top chords, and each of the slopes. Y is going to be easy to find. How big is Y? 30 feet. Very good. How do I find the slope on this piece right here? Well, it's blank over 12, P1 over 12, right? Equals, what's the rise? 10, what's the run? 12. I cross multiply and divide, I get 10. So that's a 10, 12 slope on that side. Does that make sense? On the other side over here, it's P2 over 12 or blank over 12. What's the run over here? 30. What's the rise? 10. I cross multiply and divide there. I'm going to get 4. That's a 4/12 slope. So I've got a 10/12 slope and a 4/12 slope. How do I find J1 here? Ten squared plus 12 squared, right? That comes out to be second square root 10 squared plus 12 squared. 15.620, we'll call it. J2. Careful, you're not using the slope, you're using the rise and the run. There we go. That's the square root of 10 squared plus 30 squared. 31.623. Okay, we've got about 14 minutes left. I'm going to give you guys that time. I want you to work on these. I want you to work on getting up through number 68. So some of you may have to start at like number 25. I'm hoping you did at least some of the first page. Well, no packet would be an issue.